Oh, sorry. I was waiting for the computer to do something else. This is video C17, and we are now going to start to talk about combinations. So first thing, fundamental counting principle. Then we did permutations. And we kind of did permutations where elements were not all different or you had some repeats. Fourth one is combinations. And there's combinations from one set and there's combinations from two sets. Okay, so here's our intro combinations. So imagine, if you will, the students have decided to organize a golf tournament with a twist. Participants are allowed to use 3 golf clubs from a putter, a 3-iron, a 5-iron, a 7-iron, and a 9-iron. The letters P, T, F, S, N, each representing a club, are written on paper, and each student gets to select 3 pieces of paper. How many different arrangements can the student select? Well, let's see. I do 1, 2, 3. So we're looking at arrangements. There's a magical word. And that means permutation. Oh, or FCP. I guess I could do it much easier. Permutation. There are 1, 2, 3, 4, 5 clubs. And you get to choose 3. You get to pick 3. But this would also be 5, 4, 3. 1 should give us, so we can see, 5, permute, 3, 60, and 5 times 4 is 20, times 3. Okay, so the key is there's that many different arrangements. I'm lazy. I borrowed this from an old textbook. And I copied this. I'm sorry, it's at an angle, but I didn't want to retype all that stuff. But here it is. I didn't make you write it out. You didn't want me to write it out. It's there. So we got putter, 3-iron, 5-iron, putter, 5-iron, 3-iron, 3-iron, 5-iron, putter, 3, putter, 5, 5, 3, putter, and 5, putter, 3. If we look at that, it's the same 3 clubs. Well, there's a difference. If I'm going to go golfing, it doesn't matter what order I pick my clubs. Now I've got the 3 clubs. I can use them in any order I want. And I can say that because I used to work at a golf course when I was in university. You know, I watched the guys play golf. Okay, here we go. So if this is all the same, I don't care what order you hand it to me, it's a putter, a 3-iron, and a 5-iron. Okay, this one is a putter, the 3-iron, and the 7-iron. Same thing here. There's only 3 letters in there. You're just rearranging them all the time. And it's the same all the way across. So there's really only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And sets. So notice sets versus arrangements. Those are 2 different things. It's like if there was a door prize and all the door prizes are the same, you don't really care whether you get the first prize, first one, second one, or third one. However, if the first one is $1 and the next one is 10 and the third one is $1,000, you're going to be a little more excited about which one you win. Okay, so for combinations, here's a set. There it is. Most importantly, order doesn't matter anymore. Okay, so talking about these 60, there's 60 different arrangements there. Those are all permutations. There's 60 different ways that you can arrange 3 out of F, S, and N. Right? So 5 permute 3 is 60. different arrangements, but when we actually look at it, it physically got this stuff. There's only 10 different ones you can get. So you've got a putter, a 3, and a 5. And if you go over here, there's no putter involved, right? So that's going to be a different arrangement. So each entry is a permutation, an arrangement. So there's 60. But each one of these vertical columns, by the way, here's a math tip for you and a computer tip. If you use the word column, it refers to up and down. Rows are what is considered to go across. So each one of these columns that I'm happily circling is a different combination of clubs. And there we go. Now, there's 2 pages for this video because this isn't very much. Right, so page 2, here are the magic words and magic things to watch for. The biggest thing is just going to be careful reading to determine if a question is a permutation or a combination. I guess I should have added or. FCP. For the most part, students can usually recognize a fundamental counting principle question, but it's these 2. So for a permutation, take your little highlighter. Order matters. Order doesn't matter for a combination. Some of the key words, and I tried to make them parallel, kind of like the same. So a permutation is electing a president, a vice president, and treasurer, because those 3 people have different jobs. Someone looks after the money, someone organizes stuff, and I don't know what a VP does, but it's different, right? Whereas if we elect 3 people on a committee combination, it just means, okay, we're all gonna go do the same thing. We'll figure it out ourselves. Okay, so a permutation is winning the door prize if the prizes are different. So it matters whether you win the first one, the second one, or the third one, or this one where the prizes are not different. So it doesn't matter which one you win, you're still going to win the same thing. So first, second, and third, doesn't matter. Okay, so if you're playing cards, so maybe, and I really had to think, playing solitaire, you guys play War or Snap? Okay, any kind of a card game where you can't shuffle your cards, you can't arrange them in your hand, right? If you're playing War, whoever gets the highest card wins. Then if they match, 3 cards flip. No? Check it out, it's fun. All right, whereas most card games like poker and euchre and hearts and crazy or Uno, you can just organize them in your hand. So it doesn't matter which card you get first. Right. If you're talking about making words from letters, then war arrangements, okay? Oh, arranging is there. Then you are looking at permutations. If it just says how many groups of letters, if you're talking about a group, order doesn't matter. Lotto 649 is a combination because it doesn't matter which order you pick your numbers, as long as they match, then you're rich. Okay. All right. Sometimes you get the question that is simple as how many permutations, how many combinations. Hold on. I'm gonna add combination lock in there because that's the tricky one. I figure that's just a bad name. But if I start talking about permutation lock, people are gonna think I'm a wingnut. So, order matters. Let's say you're making pizza. You want the crust and the tomato sauce and fillings and cheese, right? You don't want cheese on the bottom and then the crust. That'd be nasty. Lasagna. Or as opposed to something like a salad or a casserole where you dump it all together, mix it up, and whether you put the noodles in first or last, it's still gonna be a tuna casserole. Okay, When you get repeats, remember, there's going to be one guaranteed boom, and that has got a special formula. For combinations, I can't think of a situation where you're going to have repeating elements. So it's the moment you have repeating elements, you're going to be over here. Excuse me. Keyword here is look for arrange or line up. I guess organize would work too, but those two for sure. Whereas we're just talking about choosing. All right, and as an added bonus, let's take a look at the very bottom. We have a formula. Okay, your combination is always going to be less than your permutation number. And here we go. So NCR, and the N is total number of elements. R is the number you are picking. Okay, so you can think of it as, well, here's the formula you can use, but really what it is, it's taking your permutations and dividing it by the number of ways you can arrange stuff. So when you do that, you're getting rid of the number of ways that you can arrange stuff. Let's just go back to the golf club thing. We got rid of it. So we had it figured out that there were 60 permutations. So NCR is equal to NPR for R factorial. And there were 5 different clubs, and you had to choose 3. So that's going to give you N, oopsies, 5 permute 3 factorial, which we said that was 60. And the ways 3 factorial is 3 times 2 times 1. That's going to be 10. Whoops. That's going to be 6. My bad. Which gives me a final answer of 10. But you know what, guys? If your magical calculator, whoops, has a permutation button, it's going to have a combination button too. And I just need to go 5, second function, whoopsies, nope. See how I did a P there? That's not what I want. 5, choose, 3, done, 10, end of story. Okay. So the only thing I think I should do just to finish this up, I just want to show you what this would look like using the formula up here. Okay. So, right, truth is, use your calculator. If you can't, you can always do this, but it would be, I'm going to squish it in here. In factorial, so we're going to go 5, choose 3. So that's going to be 5 factorial over n minus r. 5 minus 3 factorial times 3 factorial. There's a point to this. 5 factorial. 5 minus 2 factorial. So these two bottom numbers should always add up to that one. And just because I'm going to show you what it was like in the old days, keys. Before the fancy calculators, we would go 5, 4, 3, 2, 1. Let's do 5 factorial. 2, 1, 3, 2, 1. There's your 2 factorial, 2 factorial, cancel, cancel, cancel into there. Goes twice, 5 times 2 is 10. So y'all should really appreciate that nice little combination button on your calculator. Thanks. Have a lovely day.